Well, good afternoon, everyone. Firstly, it's a pleasure to see so many of you supporting us by your attendance. Thank you very much. I'd like to pay tribute to our First Nations people, and in particular to those who have served, are serving, or are planning to serve in our Defence Force, and in that sense, on our behalf, I pay tribute to First Nations people. It's a great pleasure for me, in a very short moment, to hand over to our event coordinator, Ron Lyons, who'll introduce our guest speaker. And as many of you would know, Chris has a very distinguished career, but is also at this time a member of the board of RUSI New South Wales. My role as president at this time is roughly equivalent to the role of the appendix in the human body. At worst, it can do no harm. At best, it should be removed as quickly as possible. So I will in fact now ask our event coordinator, Ron Lyons, if he could do a more formal and appropriate presentation to introduce Chris.
Thanks, Michael, and good afternoon, ladies and gentlemen, and welcome to the third of our monthly lecture series for 2023. The overall theme of our activities in this 6 months is Australia's security challenges, and the title of today's lecture is AUKUS, a tripartite foundation for Indo-Pacific security. And as Michael said, it'll be presented by Captain Christopher Skinner, RAN retired. The recent announcements and meetings of the AUKUS Prime Ministers and President Biden have highlighted the value and enhancement of the agreement. Christopher Skinner served for 30 years in the Royal Australian Navy as a weapons and electrical engineering officer in 6 surface warships in CETO, the Vietnam War and in Northwest Indian Ocean surveillance. His shore postings included involvement in the Oberon-class submarine weapons update project and as an initial project director of the Anzac frigate project. Christopher's involvement in defence matters is wide-ranging, and among them he is the Nuclear Engineering Panel Secretary for the Engineers Australia Sydney Division. He's also the chair of the Subs Tech 7 Technical Committee for the Submarine Institute of Australia. He's a counsellor on the New South Wales division of the Australian Institute of International Affairs, and as Michael has said, Christopher is also a board member of this institute. Ladies and gentlemen, would you please welcome our speaker, Captain Christopher Skinner.
Thanks, Ron. I'll get straight into it. Very much welcome your interest to be here this afternoon. There are some key messages that I'd like to share with you and perhaps raise some interesting debate after I've finished speaking. I'd just like to point out this title is different to what Ron just stated, and it's important to note the difference. This says Australia's security. That seems to be the conventional wisdom, shall we say, of the whole community, not just people like ourselves. But the title that I put forward and which Ron mentioned is a foundation for Indo-Pacific security. And the reason I mention that is because I hope to demonstrate to you, or at least persuade you to think about, the reality that Australia faces in taking a greater leadership role in the Indo-Pacific. And I think that's been the underlying motivation from both the US and the UK, and perhaps other countries, in encouraging Australia to take a larger role, which AUKUS is a manifestation of that. So let's move on. There's an abstract there for the record. This is what I'll cover in the talk. Some of it is a recap on some material that I presented a year and a bit ago, but it's important to put it in the context of moving into nuclear propulsion. It's more than just a technology. It's a whole new culture and a whole new process to involve the community. And that's why I put a lot of emphasis on those aspects, because they need to be shared and debated and ultimately a consensus arrived at. Now let's talk about the tripartite relationship. And I might say, didn't come through perhaps in that earlier slide, but I spent nearly 5 years in the UK doing my engineering degree and then Royal Navy engineering, weapons engineering courses. And I've spent more than 5 years in the USA on 3 occasions, the most recent of them in Washington DC, actually working within the United States Naval Sea Systems Command. So I feel I have a particularly personal insight into how both those organisations actually work, and to note the importance to recognise the different cultures of which Australia is the beneficiary of having experienced both. And we can learn the good points from each of them, and we can refine our own better composite way ahead. Now the UK, the Royal Navy has had nuclear experience right from the beginning. They were the beneficiary of the US in sharing that information, but then they've since then done it all themselves, and that was very much the intention of Admiral Hyman Rickover of the US Navy. He shared the initial information and then told the Brits to get on with it. And because they had a very advanced nuclear industry, nuclear science and technology, they're a nuclear weapon state and so on, they relished that. But getting that initial start from the US was a big help to them. Nevertheless, the Australian Navy continues to follow pretty much all of the Royal Navy culture. And one aspect in particular that I draw to your attention is that in Australian naval warships, we tend to have 4 or sometimes 5 departments: supply, warfare officers, seamen and so on, marine engineering, which includes the nuclear propulsion when appropriate, weapons engineering, and in many cases an aviation department. Now, in the aviation and seamanship departments, there's no hindrance to rising to command and then higher rank. It's part of the same group. But that does not apply in supply, and it does not apply in engineering. And so people like me, we rise to the level of a department head in a ship, and then move into squadron and base and other industrial type activities. And it's important to mention that because the US Navy is quite different. They only have 2 departments, sometimes 3. A supply department, very much like Australia and the UK, a unrestricted line officer, which is seamen and everything else, and they do have a group called engineering duty officers who do not serve at sea. They are the people who run the shipyards and industrial activities, and they don't really, they're not really relevant here. But the reason I mention all of that is that the engineering department heads in US Navy ships and submarines are unrestricted line officers. They have a very good engineering education, but they are not in a career structure of engineers, if you see what I mean. Now, that will come into more and more important emphasis as Australia moves forward, because initially we'll be spending a lot more time with the US. We've done it before when we acquired American warships after the Korean War and later, American aircraft, and we've worked in a very flexible way with the US Navy in many respects, and I've had that experience myself to some extent. But there always was this difference of culture and career progression. Now, the USA, they invented the nuclear submarine thanks to Admiral Rickover, and they also have very structured written processes that they follow in all of their activities, engineering and nuclear being no exception. What does Australia bring? Well, over 100 years ago, 1914, Australia acquired its first 2 submarines. One of them was lost through accident, another during the Dardanelles campaign in Sea of Marmara. But we continued on for a couple of decades with further submarines, and then they all got too difficult or too expensive or both. And when we came to World War II, we had no submarines. Fortunately, the US Navy, and to a lesser extent the Royal Netherlands Navy and the Royal Navy, were able to deploy their submarines to the Indo-Pacific, base them in Brisbane and in Fremantle. And the Fremantle was the largest collection of submarines in the Southern Hemisphere, in fact. But we had no Australian submarines. We saw the light after World War II and Korea and acquired our own submarine force again, and that all kicked off in 1967. Okay, well, AUKUS has got so-called 2 pillars. The one that I'm not going to talk about much is so-called Pillar 2. It's the sharing of advanced technologies that are relevant for national and regional security. Australia has some real capability in some of these, in quantum computing, in artificial intelligence, but then so does everybody else. Cyber security, maybe. Information warfare, that's not technology, that's propaganda. That is winning the mental war, the media and so on. And I think we're still playing cricket rather than some other game in that area. So there's much we can learn, I suspect. Robotics we're good at. Innovation, well, we could be. We've got a lot of good scientists, but we're not very good at commercialisation. So there's an impediment which we have, which, as Professor Findlay of Griffith University pointed out a week or so ago in The Australian, does not apply in the US or the UK. The universities there have found a way to work well with industry. Australia has not yet discovered that, but we very much need to. Now, what has happened, of course, through AUKUS is creation of this nuclear-powered submarine task force, Vice Admiral Mead, and they've done a pretty good job. This is what you will find on the web if you go there to find out more about it. I'm not going to just regurgitate what you can find there. It's very well documented. The document that's showing here has got about 40 pages. It's very readable. It's been fully cleared through all 3 countries, governments and so on. And it's reasonably informative. It leaves a few questions and so on. What I think, though, is of most importance is the continuing negativity in the media about $368 billion, which is absolutely inappropriate in terms of the focus of the media debate. That figure, which is just an estimate if we follow the progression that has been proposed, is over a 30 or more year period, and as such, it's 0.15% of gross domestic product. And since we're in the situation of discussing coming to the realisation that 2% GDP isn't enough, let alone some lower figure, 0.15% for a nuclear submarine capability I think is pretty good value. This is another part of a document that the task force has published. It's very readable, and I draw your attention to it. I'm not going to labour it. Now, of course, the question always arises, why on earth are we talking about nuclear propulsion in the first place? Well, this report, which was authored by Rear Admiral Peter Briggs, Royal Australian Navy retired, with several decorations, who was also, as a commander, in charge of the Submarine Warfare Systems Centre here in Sydney on South Head, where the submarine weapons upgrade project for the Oberon class were conceived and implemented as a very highly successful program, which in some ways has been continued on into the Collins and looks like even being continued on into the SSN AUKUS, because the Brits have decided to go the way that Australia wanted, which was to keep the US combat system and weapon suite, which is largely a derivative of what was done back in the 1970s and 80s at the Submarine Warfare Systems Centre here at South Head. Now, why do we bother? Well, nuclear propulsion is advantageous for several reasons. The most obvious one that everybody understands is that it removes the need for periodic snorting to recharge batteries, a time when the submarine is noisier and more easily detected because of the snort and the wake from that. But in my opinion, and I'm just a humble engineer, the real issue with nuclear propulsion is speed. If you're a submarine that can do a speed on a regular or on a continuing basis of, let's say, 8 knots or 10 knots, you're slower than any of the likely target vessels that you might be wishing to engage. Therefore, you have to position yourself so that they come to you. If you're in a nuclear submarine with a top speed of 20 plus knots, you can overtake them. So your tactical approach, your concept of operations is totally different. And that to me is the most important difference. There are other factors as well, as I mentioned, about detectability and so on. And there are a couple of downsides as well, because with nuclear propulsion, you do need to keep the reactor cool 24/7. Once you've activated a nuclear reactor, it stays hot for practically forever. Even if you shut it down, it will then take quite a few hours, if not days, to come down to a regular temperature. But anyway, forgetting about that, just in normal operation, you've got to keep it cool, and that means some pumps need to be running. Now, Admiral Rickover kicked it all off, and I draw your attention to this, that this happened before there was ever any nuclear power station. So the previous argument that Australia could not entertain nuclear propulsion because we didn't have a nuclear power industry is pretty flawed, because there never was a nuclear power industry when the Nautilus was designed and built. In fact, Admiral Rickover somewhat reluctantly went off and started the first nuclear power station at Shippingport, I think it was in Pennsylvania, but his real interest was in submarines. And I might say that there are some other fairly important differences that I'll bring out now just in passing. even in those days, you did need to refuel nuclear submarine reactors, but you could only do that on a regular cyclic basis, which for submarines, a full cycle is typically 10 years operating and then 2 years maintenance, and during which time originally you had to refuel. And that, I won't go into all the detail of that, but it's doable. I've got a colleague that I work with, former Royal Navy Marine Engineering Nuclear Head of Department, and also in leading the team designing the nuclear plant for the current suite of, or the current class rather, of Royal Naval submarines, the Astute class. He's been through a refuelling, and he says it takes a couple of years, but that's just because of all the checks and balances. The problem, though, is that when you compare that with a nuclear power station, they refuel every 18 months. And you don't have to worry about shock and vibration or battle damage or various rapid changes in speed or other propulsion demands in a civil nuclear power station. So I mention that because there are significant differences as well as many similarities. So what do we mean by a nuclear power plant? I won't dwell on this, but this is the best summary slide that I've been able to find. And what you're looking at here is two major compartments at the stern of the submarine. The reactor compartment is an unmanned, that is uncrewed compartment, and the primary circuit of the pressurised water reactor starting as steam from the reactor itself and then condensed and back to water to generate steam again, is all contained within that reactor compartment. It's shielded, and the net radiation dose that extends beyond that compartment is very low indeed, and in some cases is lower for a crew member than they would experience on the surface in normal open air. The right-hand side of the diagram, the remainder of it is the secondary circuit where the steam is generated again in this secondary circuit, and it drives turbines, goes through a condenser and then circulates again. That's all technology that's been around for 100 years. There's nothing really new in any of that. What is challenging is reducing the radiated noise and dealing with the necessary possibilities of an accident occurring or a failure of some component and so on. And what's most important is the cooling effects of that on the primary circuit must always be considered. And so ensuring there is a cooling water supply at all times, 24/7, even if you're in dry dock or anywhere else, is vital. And that's something that requires quite a lot of additional planning in maintenance activities. I won't dwell on this. This is just a notional submarine. In the middle of it you can see the reactor compartment, which, as I mentioned, is uncrewed. But what's just aft of it is the manoeuvring room, which is in the middle of this slide, and that's where the watchkeepers control all of the two compartments that I've just described. And a typical watch on a Royal Navy submarine, which I have information on, is a watch leader, two other qualified officers, a warrant officer, nuclear qualified, and three other ranks who are moving around in the compartments, checking the actual condition of the machinery and taking measurements and so on. And I won't dwell on it any more than that, except to say that the living part of the submarine is forward of the reactor compartment, and there is a shielded walkway or tunnel for the watchkeepers in the propulsion suite to go back and forth to perform their duties. It's very demanding, but there are 60 years of experience of doing this without incident. Even the very important fatal losses of a couple of US nuclear submarines, neither of them were caused by nuclear accidents. They were caused by other failures. The Thresher in the first place led to a whole new regimen in terms of quality control, for example. But the failure was not in the nuclear plant, which has always been subjected to the highest levels of control, thanks to Admiral Rickover. Now, in 2019, it occurred to a few of us that nuclear propulsion was something we really should get serious about, and we started thinking about it much more closely. Later in that year, the Submarine Institute ran a half-day seminar, and the attendees, including the Chief of Navy at the time. And from that, Professor Tom Frame edited this book that's on the screen now, and it says Australian nuclear industry starting with submarines, ? And that was really what initiated the whole process of thinking through AUKUS. This is just a snapshot of a Virginia class current production out of the US, and here's a similar one for the UK. These are Astute boats, and you can actually see on this the shape of the submarine. It is described to me by a mechanical engineer as a very simple and regular structure. It's basically a cylinder with domed end caps, and that cylinder is the same shape all the way through forward to aft, and contains several different sections, one of which is the reactor compartment and another one is that propulsion. And then outside of those two end caps, at the forward end, is a big sonar dome and anchors and other, possibly also forward control planes, although often they're in the sail or on above the pressure hull. And in the aft end, there's a stern seal, the propeller shaft, and the control surfaces, rudders or X-planes. But what you can see from this is on top of that cylinder is a structure which is the casing, which gives it a freeboard when it's on the surface, and is also a convenient way to give hydrodynamic streamlining and to put in other fixtures, especially sonar transducers. And just, I like to show this one because this gives an idea of what a section of a submarine looks like and how do you get all that gear into it. You don't put the cylinder together and then try and get it in through little holes. You slide it into the section before you then weld them together. And this shows how that's done. It's called a raft, and the raft itself is insulated acoustically and mechanically from the pressure hull for the benefits that provides. Now, one of the really big challenges that we've never encountered before is dealing with the entire nuclear fuel cycle. And you'll hear various people making statements saying, oh, well, Australia's submarines will have the nuclear fuel welded into the reactor compartment and, that's all we need to worry about. somebody will supply it to us, and when we're finished with it, we'll give it back to them. That's quite inappropriate for several reasons. Firstly, Australia is a large source of uranium ore anyway. By the way, the US and the UK still depend on Russian nuclear fuel, believe it or not, because they've given up some of the capability that they had in manufacturing it themselves. We're not allowed to because of legislative constraints, but nevertheless, we do play that role, and we're talking about what to do at the end of that process. And ANSTO, the Australian Nuclear Science and Technology Organisation, has invented a vitrification process called SynROC, which is how you take the residual hazardous waste and encapsulate it into this glass-like material before putting it into its final disposal place. But what matters more through this is just because you've got a reactor where you don't have to refuel during the life of the submarine doesn't mean that that's all you need to worry about. You have to operate the reactor and to maintain the chemistry of not only the fuel itself, but the cooling water flow, so that it does last the length of time that you intend. And that requires some deep knowledge of the chemistry, the physics, and the day-to-day operational constraints. And you can't do that if you don't have a full understanding of what is the full nuclear fuel cycle. And I won't dwell on that anymore, but it's absolutely essential that the responsible people on watch in a submarine and in the shipyards and any other support organisations do fully understand every step of this fuel cycle. This is what it looks like, and I won't bore you with the detail, but there are a few loops that can be bypassed. The right-hand bottom one is skipping the reprocessing of spent fuel, which is sometimes done for economic reasons. And there's also, in the middle of the diagram, a reverse loop for the plutonium that is one of the generated products out of fission, which is then mixed with other fuel to produce a composite fuel material that can be reused. This is well understood. ANSTO is a leading participant in this type of physics and technology and science, but we haven't done it for a submarine before, and we need to really concentrate on getting enough people with the right level of knowledge to do it safely and securely. Now, what sort of infrastructure is required? Well, I talked about some of these things already. I won't dwell on them, but they're in here for the record, if you like. One thing, though, that I will mention is that when the spent fuel is removed from the reactor at the end of its the period in which that fuel is to be used, it remains hot for several years because of the ongoing activity of the various fission products breaking down and radiating, and in the process producing quite a lot of heat. And so typically after the spent fuel is removed, it's put into a cooling pool, let's say for 10 years, and during that period the radiation diminishes, and so does the heat offtake. Now, construction of nuclear submarines has been talked about, and under the AUKUS process, that's something that we would do in conjunction with the UK, and that's a very positive step that means that we're dealing with known quantities, BAE Systems produce the UK submarines. They're well known in Australia, not for submarines, but for other activities. Rolls-Royce are the reactor designers and builders. Again, they're well known in Australia, but not for submarines. But we've got a cultural background, so working with BAE Systems and Rolls-Royce should be straightforward. We need a proper regulator, and currently that's provided by the Australian Radiation Protection and Nuclear Safety Agency, ARPANSA. It seems very likely indeed that there will be a specialist naval reactor group, but I'm predicting that they will still need to be licensed or approved by ARPANSA in principle, but that's to be determined. I'm not quite sure how that's going to work out yet. It does require a different point of view. As I mentioned earlier, the environment in which a naval reactor works is not the same as a civil nuclear reactor. Even a small modular reactor of much the same power level is being refueled on a much more frequent basis, and secondly, does not have to withstand shock and vibration and battle damage. Now, workforce, big challenge. Dr. Edward Obbard, O-B-B-A-R-D, leads the Nuclear Engineering School at the University of New South Wales, the only such school in Australia right now, although there are several other universities that are thinking about getting started, but even then they're still talking more about the physics than they are about the engineering. But Ed Obbard has been published in the Australian and other newspapers over the last couple of months, pointing out the large number of people who will be required. Fortunately, the time frame it's feasible. This book here, I just show it to show that there is some sort of background that people can read to find out what it's really like in this sort of area. We will need a shore training and technical support reactor. This is the one the Indian Navy is using as they're trying to build up their nuclear submarine force. They've only got a couple at the moment, one of which was from Russia. But I think over the same time frame as AUKUS, we can expect that India will produce several more. But this is what they use to train their nuclear submariners and others, shipyard workers. If we get cracking with what we're doing for AUKUS, it will also cover some of the requirements that could be used in consideration of civil nuclear power. And I'm not going to rave on about it today, but I would point out that there is a growing body of thought that says that 100% renewables is not feasible if you want a reliable and reactive grid. Now, I'm not going to argue the point one way or the other, but it appeals to me that we should not exclude the contribution of nuclear to a emission-free future electricity generation. And if we take that view, then we will be getting valuable experience from AUKUS. Okay, I just show this as a sort of by way of illustrating something. I'm a member of the Australian Institute of International Affairs. The New South Wales division has 6 interns who are new graduates in philosophy, politics, economics, and similar faculties. They're not technical people. But we set them a debate on whether AUKUS was in Australia's best interests or not. And interestingly enough, they said that they're worried about AUKUS being the value for money. They are worried about Australian sovereignty because there is a perception that we would be increasingly reliant on US technology and hence political influence. And how is AUKUS affecting our relationship with China, which they're not very impressed with the whole idea, not surprisingly. What they were not worried about was the nuclear aspect. That they just thought that was perfectly okay. They're worried about these geopolitical issues. Now, timelines, I won't expect you to follow this exactly, but this is my summation of what AUKUS is talking about. Initially, in the next few years, we will first of all be starting the Collins class life of type extension, which is a 2, possibly 3-year process, but will dramatically improve the reliability and in some cases performance of onboard systems. Don't expect the first of them to just instantly work as required. There'll be the usual first of class sort of issues and so on, but we've got really good experience, and with help from our overseas colleagues, particularly Saab, who are now the parent of the designer of the Collins, we'll get through that and we'll get good value out of it. But it's a conventional submarine. It has that slow speed I mentioned, and it has to snort. So, you know, the days are numbered, but they are very fine submarine force after a long teething and start. But they'll keep going into the early 40s, all being well, or certainly the late 30s. Now, meanwhile, provided we invest quite a bit into the infrastructure needed, then the US Navy, and to a lesser extent the Royal Navy, will start basing their nuclear attack submarines in Fleet Base West, which is Navy call HMAS Stirling, on Garden Island West. It was always designed to have visiting nuclear warships from day one, although they didn't make a big fuss about it. Nevertheless, because of things like dealing with accidents or incidents, the need for continuous cooling, as I mentioned, for the reactor, you do need an investment of several $1 billion to ensure that it's safe, secure, and that it works efficiently. And assuming that can be done over the next 2 or 3 years, then we'll start seeing US Navy boats operating out of Fleet Base West. And the big advantage of that, of course, is Australian submariners can form part of the crew and gradually meet the various levels of qualification and licensing, and probably not up to command level, but certainly up to department head level. I could see that being done readily through that basing. The next stage is for Australia to purchase 3, possibly 5 of the same class, the Virginia class, and they would be in 3-year intervals starting in 2033. So 10 years from now, we got to be ready to operate an Australian HMAS whatever SSN. That's quite a big ask, as I hope I've illustrated in a few ways. And meanwhile, we'll be working with the Brits to contribute to, and don't know exactly how much we'll contribute, to the design of the SSN AUKUS, which is a derivative, I believe, or a further development of the current Astute class. But the sort of differences that one might expect is the increased capability with regard to uncrewed underwater vehicles. Now, they may or may not be recoverable. Usually you'd like to get them back. But even if they're disposable, we're talking about something more than a torpedo. You know, the current Mark 48 torpedo is wire guided. It's got a range of 10 plus nautical miles. It's highly manoeuvrable, and it's got very good feedback from its own onboard sensors back to the submarine so they can control it to optimise the engagement. A UUV would be expected to be more versatile even than that, and if the wire broke in a torpedo, the torpedo will still continue the engagement subject to the rules of engagement that have been built in, but you'd want a bit more assurance if you're dealing with UUVs, particularly if they're lethal, if they've got warheads. Anyway, that remains to be seen. I just hope, though, that we can finally grow out of this very immature attitude in Australia that any time a major complex program changes in any way, that it's some sort of a failure. There's absolutely no way in the world that the SSN AUKUS can be fully conceived, designed day one. It's a progressive process. It's very well described in the literature. It's just that most people don't seem to know about it. And this will definitely happen with SSN AUKUS. And in some cases, it's going to be a two-way street, because the combat system and the weapon suite that we've said we want is the American one, which we're already a part of. We're part of the consortium continuing to develop the Mark 48 and the ANBYG-1 combat system, combat control system, and the Brits are going to go with our choice. We're going to go with their choice in terms of propulsion, and it's going to be a very interesting combined effort. But as I've said earlier, we've got a lot of experience of working with companies like BAE. What I worry about, personal view, is that we make sure we involve all of the Australian expertise, such as the former Australian Submarine Corporation, ASC, and other companies who've got very real knowledge and experience to bring to bear. I'm not going to dwell on this. If you go online, this is what you get from AUKUS propaganda, or publicity, I should say. I don't find it very easy to follow at all, but all the same information I just ran through is in that slide. Why does it matter, and why am I talking about Indo-Pacific? Well, this was an interesting slide. The green areas are the offshore territories and exclusive economic zones that the US has. The blue are the Brits, and the yellow is Australia. And interestingly enough, we've somehow managed with the three countries to cover the full circumference of the Earth. And that's why I think that what we're talking about with AUKUS is more than just a technology transfer, and it's more than just something that's helping Australia protect its own interests. This is something that truly does have a basis for a maritime view across that entire scope all around the world. Now, you may not agree with that, but I think that it's very important, and these are the reasons that I give. Even NATO's starting to see that Indo-Pacific is of greater importance, inviting 4 countries to the NATO summit. China's all very worried. They don't want to see an Indo-Pacific version of NATO created. What I think most people are focusing on unnecessarily or unhelpfully is what happens with Taiwan. I'm not going to try and predict it, but one of the wargaming scenarios that I've suggested, along the lines that the Lithuanian minister has called for that this take place, is in the event that China attacks Taiwan and Australia is requested to contribute to its defence, and we decide in our wisdom to provide materiel in the same way that we are to Ukraine, but not to commit combat forces. And China says, we'll get in touch with all these oil fuel shipping companies that ship from the Middle East to Australia, and say that they might think better about doing that. And all of a sudden we might find we've got no oil fuel because of what we're doing in Taiwan. Notice I didn't mention anything at all about a direct invasion route from China to Australia. That's the least likely event of all. What is possible is interference with the two-way trade, but it's not in China's interests to cut down on iron ore or even on barley, it seems, let alone coking coal and so on. So that would probably continue. But meanwhile, if they're pulling strings in the Middle East and cutting off our oil supply, we might have second thoughts. Anyway, I won't dwell on that. So, conclusions. A nuclear submarine capability is much greater than what we currently have and is more effective for what we need to be able to do. AUKUS is projecting a three-stage or three-phase strategy that looks sensible. It provides not only for the submarine capability per se in the Indo-Pacific, but it also provides a very good learning opportunity for Australian submariners and shipyard workers. And I forgot to mention that there's already a commitment to take several hundred Australian shipyard workers and embed them in the UK and US shipyards to gain experience and to seek the qualifications that are necessary. And by the way, they're not identical between the US and the UK, so that needs to be carefully thought through as to whose rules we're following at wherever they're going to be employed. The entire nuclear fuel cycle must be addressed, and I won't dwell on any further on that, but that means that we need to have a coherent and convincing story on what we're going to do with spent nuclear fuel, even though it isn't going to be required immediately. People need to be assured that it will be done effectively. AUKUS, I believe, provides a tripartite foundation or basis for global stability in conjunction with other major players. And I'm not saying that that other countries such as Japan and Korea and France and Indonesia are not vitally important also. But it will enable Australia to step up, be counted, and to make a real contribution to the international security as well as our own. And finally, I think that what is steadily being acknowledged by countries in the region is that this is something that's timely for Australia. Australia is able and has a convincing approach to be able to do it, and it's something that's in the whole interests of stability and security in the Indo-Pacific. So I would welcome discussion.
Good day, Chris. Bradley Pirrett, journalist, writing for the Canberra Times, sometimes Strathspey, etc. A couple of questions, if I may. First, the very common one, what's your view about the idea of not bothering with SSN AUKUS and just getting Virginias delivered as fast as the Americans can deliver them? 8 or even more. Second question, where do you think 8 nuclear submarines fits into the idea of having 2 bases? Because if you split them, that means 4 submarines at each base. These are expensive bases, complicated bases, and I wonder whether or not we would really want 2 for only 8 submarines.
I'll take the second one first. It's a matter of geography and the transit time to get from one area of operations to another, and it's a long way from Fleet Base West to the Southwest Pacific. in terms of why don't we just get lots of Virginias, the US, especially the US Congress, wouldn't permit it. We're nowhere near up to the level that they could entrust us to operate, let alone maintain those boats. So we've got to get there steadily. And I'd say from my own experience of working in and with the US, they think through the entire process, not the stuff that's up in the headlines, but the whole process of safely, securely and efficiently building a submarine capability. And I think they've done a very good job in what is proposed with AUKUS to even contemplate just going straight into Virginias as fast as possible. I don't think it'd be any faster anyway, but even if it were, it would raise all sorts of unrealistic demands in terms of training, recruitment, building up infrastructure, the processes, getting the regulator even in place. At our usual sort of glacial pace of some things that we've followed in the past, it wouldn't be any faster than what's already been proposed.
I'm a member of RISC, but
Director of Aerospace Developments. The submarine, does that use desalinated water for cooling?
I didn't catch the question.
Is the submarine use desalinated water for cooling?
Not that I'm aware of. The tertiary circulation is seawater, of course.
Yeah.
The water in the secondary and primary systems is chemically very pure. I think it's more than just desalinated. I think it's very carefully treated. But I don't have a lot of information of my own.
Thank you.
Hi, my name's Tony Bernard. I'm a member of RISC. Without being a stupid question, you've got two really good existing SSNs, American and Virginia and the Astute class, and I can understand that the new submarine will have the American technology in the combat system and weapons. Why do they need to build a completely new submarine then in the 2040s when there's two really good designs to choose from now? What's the reason for a new submarine if we're going to keep the same weapon system?
Look, that's a very valid question, which I asked myself about a year ago, and I wrote an article saying we should just build more of the Astute class, but build them partially in Australia. And what I envisaged was that the forward part of the boat, that is from the forward bulkhead of the reactor compartment forward, would all be built in South Australia, and the reactor and propulsion sections would be imported from the UK. What I was told though was that we couldn't do it in a timely manner before the Astute program shuts down in 2026, and also Rolls-Royce had shut down all their work on the reactor that the Astute uses. The next generation of UK submarines, both the ballistic missile submarines and the attack class, will have a further new reactor that's under current development. So, very valid question. If we'd not wasted our time after 2009 white paper and just said we need to go nuclear, we could have got tacked on the end of the Astute program very happily, but we left it too late.
John Hitcham, RISC member. Chris, I just noticed there for the two submarines, Virginia have got vertical launch tubes, the Astute have got none. Is that a key weakness between the two submarines?
Look, as a humble engineer, I am a bit wary about the discussion of number of missile tubes. It's a very current argument going on in the surface navy as well. The Virginia was not designed with those vertical launch tubes. It's a later block that incorporated that extra module in the centre of the boat. The Tomahawk land attack missiles, which Australia is purchasing from the US, thanks to the congressional approval the other day, can be launched out of torpedo tubes. It's not ideal. It means you have less flexibility for engagements and it's slow, but it is a reduction in capability, yes, but Virginia added it through the life of the program rather than at the beginning. What will happen with SSN AUKUS, I would only be speculating, but certainly the balance between vertical and horizontal tubes and the payload of various weapons and undersea, uncrewed underwater vehicles, that's an operational trade-off that I know has to be done, but you know, I don't have the insight to give you any sort of firm idea on which way it will go. But it's a trade-off that has to be done. And by the way, I would stress the fact that with all major defence programs, there is always a trade-off, even though people may overlook this fact and think that you always get the best of everything and whatever. It's never the case. You trade off cost, capability, crew, the sustainability. There are many factors that have to be traded off.